we are team Gen Alpha, and the problem statement that we had selected was problem statement number 6, where we had to do was updating the existing maps. So in this problem statement, the main motive was, and the main task was to get data from various sources, which is an essential part, as we need to know that this existing thing is literally there or not. So we collected data from various sources like OpenStreetMaps, Just Dial data, Wikipedia, and satellite images, and some of the third-party APIs. So after collecting the data from various sources, we need to merge them and then get and then clean the data. While we were doing this thing, we were facing problems like we were not getting latitude and longitude for various things, which was the most essential part to know where exactly this thing is existing. So first we need to do was get the data, and then we applied an LLM model, which basically took the address that we had scraped and got its latitude and longitude, and then through all this we cleaned the data and then merged all this data. I'll just configure this all these things so that all the things is getting collected. So on clicking here, the OpenStreetMaps data we are getting, we have got it. We can view it here. So this is the whole data that we are getting from the OpenStreetMap with all the IDs, name, and coordinates and all. So this was one thing. Then this is the thing that we are scraping from Just Dial, because like Google, it's kind of a Google thing. So genuine things are there over here. We are also getting some POIs here as a attribute. Later, so this is also done. So this is whole data for the Just Dial that we got, where we are getting the restaurant and all the shops data. Also, this is the Wikipedia thing. You can see that this is working perfectly, like from backend. Each thing is scraped. You can see over all of these things over here. We are getting these things. How we are collecting the data from the images by using Python code and YOLO for detecting things. So you can see this is the input image, and after the running the script Python code, we can get the YOLO detected output image, which basically detects the signboard. As you can see, the signboard, then the cycles and all those things. Yeah. So after collecting the data, we have cleaned it, got the latitude and longitude, and then we have merged the data. And for validation thing that this thing is actually existing, we have assigned some weights to each and every source that we are getting the data from. Like we have kept the weights like OpenStreetMaps the highest, then the Google, then Wikipedia and all, and then uh, the other image thing. So if a new data or a deleted data is having a weight more than 50, then it means that it is genuine, because all of the different sources have validated them. If it is not, then we'll not take it. So after collecting all those data, we are getting the final data that we need to compare with the existing data of the here maps that we are taking as a base map.
So, to walk you through the complete workflow of generating a GeoJSON map, I started by performing named entity recognition using a BERT model from Hugging Face, which helped in extracting an entity that should be represented as a point or a line string in the GeoJSON format. For that, get for extracting whether it's a point or a line string, the input or the entity that was given was names, addresses, or types from the raw text data that is present in the CSV or the JSON file. Next, I leveraged a llama model integrated with Grok for generating GeoJSON structure. The input that I provided or included in the prompt was name, addresses, latitude, longitude, and the entity type that we got from the named entity recognition step. I also included a sample format in the prompt to guide the model structure. Following this, I called the Grok model to generate the JSON to generate the GeoJSON file from the initial JSON and the CSV file that we have web scraped and you extracted from the Rapid API. So, for using the same Grok model, I converted the GeoJSON for all the JSON and the CSV file. For example, there was like Hanuman Road, Hotel Samudra, and then Mahesh Lunch Home, Juhutara Road. To streamline the process, uh, once I had all the GeoJSON, I introduced a weight assignment system to prioritize the data resources that was necessary for the further step for comparing and validating the location. Uh, for example, the data from Mapillary received a weight of 5, the Overpass data's received a 4, and then Just Dial Wikipedia 3 and 2 respectively, and Rapid API, since it's user generated, received 1. Then I created a unique set of address name combination from each GeoJSON file and dynamically updated the weight based on the weight assignment that we have default by default assigned. If the same feature across multiple trusted sources, the total weight increased accordingly. With this weight, calculated a confidence percentage. Features with weight under 4 were assigned 50% confidence, while those above was scaled proportionally ranging from 90% to 98%. Finally, I merged all the GeoJSON files, removed any null or empty entries, and ensured consistency across the dataset. The result, as you can see, is a clean consolidated GeoJSON file enriched with weights and confidence value.
So now here we will go with the thing. So now we'll inject the data that we just collected after all the processing. So we submitted this file that we had got after the merging of the data. Now uploading the base map data, which is the here maps, and then over here we will compare the data, and here we'll do the quality check, and then after the um, comparison of both the data, we will get the final code, which will be uploading in the here map xyz extension. So now showing you the backend for the comparing thing, where we are comparing the file 1 data, which is the GeoJSON for the base map which is there, and file 2, which is the merged data of all the data that we collected. So now we generated the merged data, the final output of the whole GeoJSON, which compares all the things like you can see in the terminal, and give us the extra features or the things which are deleted from the map right now. So basically the updated map data GeoJSON format we are getting through this thing, as you can see in the terminal. Yep. So now I'll walk you through the this comparison that we'll see it live. So this is the actual here map data that we had got, which is the base map reference that we are taking, and this is the all the merged and scraped data. So now I'll show you the comparison. Just a second. So we can clearly see that this shop is not existing in this here map, which is the base map. So this is how we are doing the map updation.